Welcome everybody. This is preliminary planning of logging operations using Lidar. My name is David Mills, and here we go with the beginning of the webinar today. First of all, Lidar is available. It hadn't been up to a few years ago. Lidar software, Lidar data is very dense. Let's take a look at one here. So I'm going to open for you a Lidar data set, which it comes with all kinds of different data points. Okay, here's my Lidar examples. So software can read all kinds of different file formats. We can read Lidar in the LAS format, which is what I'm going to show you. We can also read ASCII data, and Lidar often comes in an ASCII file. I've just seen a Lidar file that was packaged up as a DEM. So Lidar can come in various formats. In all cases, let's just take a look at one of these Lidar files here. In all cases, the Lidar has the option of containing multiple different kinds of data points. So here we've got ground data points tagged as 2, and then there's unclassified, low noise, water. You'll often see classifications like foliage or high foliage, low foliage. If I bring in all the points, we've got way too many for the software. If I bring in the ground points, no problem at all. There's only 1.4 million here. So I'm just going to bring that in quickly, and you'll see what that looks like. I'm not going to bother doing a selection. Also, I only need to tell our software that it's meters. But often you're working in real coordinate systems, and you want to make sure that you can do things like export to Google Earth. And so you want to set up a correct projection, whether it's UTM or BCL bears or state plane or whatever. We're going to work in that undefined at this point. So it's reading a large number of points here, 1.5 million. Doesn't take very long, and doesn't look like much until you actually put a tin surface on it. So let's just do a tin surface here. And I'm going to put on contours 50 and 5. That sounds reasonable. Let's not bother with labels. Now, this is just one little tile. And generally, Lidar comes in tiles. They're rectangular that have been created for you for convenience. And this tile contains 1.5 million points. If I had 50 tiles, I would have trouble doing this. So there it is. Looks good. Let's see what it looks like in 3D. So to create a 3D view, it takes a little bit of time because there are so many points, but it's quite capable, terrain's quite capable of doing that. Sorry, I'm jumping around a little bit here. You can see what that surface looks like in 3D. On my screen, it reacts quite quickly. Of course, we are working over the internet here, so there's a bit of a delay. So if I rotate the screen, it takes a little while before you see the results. Anyway, there you go. You can see the Lidar is accurate enough so that I can see existing roads on the ground here. There's clearly an existing road where my mouse is tracing there. And we've got the contour lines displayed on there. I calculated those. Now, let's look at a more realistic problem. I'm going to start from opening up a file that contains some initial road data. There it is. Now I wanted, this is an area of interest. I drew this. This is just a line here. And draw it again just to illustrate. You could make any polygon on your terrain and call it an area of interest. In addition, there's an existing alignment in here. I could have imported that from Shape. I could have imported it from Autodesk, AutoCAD, any kind of two-dimensional line that represents a road. We can import that into our terrain module. So file insert, and you can choose all the various different things that we read, including shape files, ASCII text, of course, surveys. If you're working in the forest, you might have some TR1 files, soft tree traverse format, and DWG, and all kinds of other formats. I'm mentioning this because these lines or corridors can be very valuable in bringing in your Lidar data. So here's a feature that I just drew with the mouse. I can move that around a little bit if I want to change its shape. And it happens to be called AOI. I named it Area of Interest. And if I wanted to create another one, I would probably do this, say File. Oh, maybe I don't know where I want to draw, so maybe I'll put in a background here first. Let's add a air photo background that I have. Now it's not a particularly exciting air photo because I just stole it from Google Earth. There it is. So let's say I wanted to include this particular rectangle in my area of interest. I could just create a feature. Let's call this AOI2. Draw with mouse. Click to create a point. Click again to create another point. So it's click again to anchor. Click a second time to anchor. And then I'm going to close it. Okay, so there, I've created a rectangle. Now I'm going to use this information to read in my LiDAR in those areas of interest. So this is kind of key. LiDAR files are really big. If I go File, Open, or File, Insert File in this case, and choose 15 LiDAR tiles, there's going to be a lot more than 1 million points. Good rule of thumb, terrain and location can handle 5 million points. So I only have 2 LAS files here, but I could have lots and lots of them. Watch what happens when I open more than one. I get a chance. It does take a little while. You'll need some patience if you have 15 or 20 of these things. It does take a little while to examine an LAS file. I'm not quite sure why. We're looking into it. There we go. So again, I only want the ground points. Now I'm in the Selection tab. So I'm importing LiDAR. My default selection says read them all. I'm going to change that to 1 in 10. So I'm going to decimate the data. I'm going to read in only 1/10 of the data for my default region. Now I'm going to add a corridor. And I'm going to select the existing road and make a 100-meter wide corridor from that data, or from that road. Now I'm going to create another region, which is a polygon. And I've got 2 polygons. I'll do one at a time. They're both called AOI for Area of Interest. Notice that when you select a polygon, you can do interior or exterior. I want the interior. And let's just do one more here, AOI2. So now in my Selection tab, I have 4 regions. The region is only reading 1 in 10 points. The first 3 regions are set to default, read them all. In other words, skip 0. Okay, let's read it in. This takes a little bit longer than reading the files without regions and polygons, but not a lot longer. And you'll see when it's finished reading them in, that we have, first of all, we would expect 3 million or so points if we read in every single point out of the files, because there's about 1.5 million per tile. But in fact, we'll get less than that. So you can see that it's read in all the data, and you can right away see my areas of interest are darker. There's more points than outside the areas of interest. Let's just zoom in a little bit here so you can see that more clearly. So this roadway here is my corridor, and that's 100 meters wide there. Let's double check that. I actually can't remember whether it's 100 meters each side or 100 meters wide. 100 meters wide, so 50 meters each side of the corridor center line, 100 meter wide swath. And then, of course, the polygon is just denser on the inside. So out here, outside my areas of interest, we're skipping 9 out of 10 points. In here, in my area of interest, we're getting full LiDAR density, and there are only 800,000 points in here. Quite a bit less than the 3 million that we would have got if we hadn't done the selection. Just to emphasize, there's no problem with reading in 3 million points. 30 million could have been a problem, so that's why you need this selection tool. Let's take a look at the LiDAR data. I'm going to get rid of that background for now. I don't want to see it. Now, I'm in the area of interest, and yet you're still seeing some dense areas and not so dense areas. LiDAR is a laser device that scatters off the ground, and you can see areas where there are openings showing up as dense points. There are obviously near the road. There are no trees, and you get a lot of scatter from the ground. And if you look closely, you can actually see scan lines in the data. And then away from the road, where there are trees, the points aren't so dense. In fact, this area right here must be particularly dense forest because the points are not very close to each other. In fact, there's a distance between those points there, measure tool, of about 11 meters. So people may tell you that you're getting LiDAR data that's 1 point per meter squared. Depends on the foliage. And watch out, because sometimes you're going to get a LiDAR file from a provider that is actually looks like a grid. The points are sitting on 1 meter even spacing. What they've done is they've made a surface, which I can do here very quickly, and they've just laid a grid over top of it and sampled the surface. So you lose the information that I can see here, which is where are the points dense and where are the points not so dense? Where am I missing data? Anyway, let's create a surface here. Now the nice thing about the method that I use, now I don't need to look at these LiDAR points anymore, so I'll just deselect them and they'll disappear. The nice thing about using the selection method that gives you all the data but thinned where you're not using it is that you get contours everywhere. So you can see the context. Now if we look closely here, I've got a couple of these orange symbols that represent places I'd like roads to go. So I'm going to start by planning a road from this point here to that point over there. Now I've created a surface, and I can actually drape a feature on here and see what the profile looks like. So let's peg a road from here to there. Now road pegging traditionally was done on contour maps with a pair of dividers. Now you can do it in software. The terrain module is great for this. And I'm just going to read in a screen layout that has that in it, pegging. Okay. It doesn't look very different, but there's some different stuff in the status window here that's going to help me with this. So I'm going to create a new road feature. Call it Spur 1. I want it to be a draped feature, so I turn elevation off and leave modeled on. I'm going to draw it with the mouse. And I'll just create my first point and click it down where I want the road to start, about there. And then I'll create another point and click it down here. Notice that in my data window here, I've got an average slope of -6%. If I pick that up and move it down a contour, oh, it's now -15%. I'm getting some nice information. I'm getting information about the length. It's 54 meters from the previous point, and the slope. Well, that's nice. How about the profile? What's the profile look like? So I'm going to create a new window, profile, and let's tile these. Now, of course, this would work a lot better if I had a bigger monitor. In fact, I do have a great big monitor, but we're only looking at a tiny screen because I'm sending it over the internet. So let's turn off auto scale. Oops, off fixed scale. There it is. There's my little profile. And is that distorted? No, it's not. Shall we put it in distorted mode? Why not? Let's do 2200 scale. So distorted at 10:1, as is typical of road profiles. There we go. Now it's going down pretty steep. Great. So, well, I'm branching off of a road here, and the grade on that road, by the way, is 3%, and we're starting to go downhill. So I better not go down too fast. We're going to have a strong grade break there. Let's say -3% for my first leg. I'm going to zoom back a little bit. Okay, we want to go up here. What if I just did that? There's what the profile looks like. You can see that's pretty steep. And you can also see that the average grade from this point to that point is 20%. Okay, well, considering it's going down and back up again, there's no way we're going to do it in a straight line. So I look at the contours and I think to myself, where's the best place to go? Well, it looks like I need to cross this valley, and I'm just going to hide the profile for a minute so I got more room in the plan here. And it looks like there's a good spot for a switchback. I think it's over here. Let's just see where we go. Pegging kind of leads you along. So here we go. We're going to go down the hill. 16%, too steep. Back up a bit. 1%, not steep enough. Okay. How about there? -4, -10. That looks reasonable. And that's a 50-meter leg. Okay. We're going to see a lot. -27. Okay. -8. -11. That seems reasonable. So we're a logging road. -19%. Holy smoke! There's a steep gully right in there. It's not clear from looking at the contours. They're only 5 meters apart. And if I go across, of course, it's going to be flat. Oops. -6%. We'll take a look at that more carefully when we look at the profile. Actually, you can see it right now. How wide is that gully? Well, I can see it right on my profile. It looks like about, I can't read the font, it's too small. 10 meters across. Oh, that's bridge width. We're not going to go down in and back out again. Let's just go right across. That makes more sense. Okay, back up the other side. Let's sort of go over to here. So we got some room to start pegging, and now I'm going to start going up the hill. 27%. Let's try and keep it around 12 if possible. 13, that's reasonable. 12, okay, there we go. And then we'll go along here. Now I could just jump along like this until I get 12%. But, you know, I think you're going to need more curves in here. So I'll go back and do shorter legs. 36, 9%, 12%, 2%, 8%, 10%, close enough. 8%, 16%, 11%, that looks good. Now this is pretty steep side hill here. In fact, I think there's a a tool that we can turn on, actually a display, that shows the side hill. So I'm just going to find that. Tin side shots, that seems reasonable. Average side shot, or left or right. Let's just use average, see what that shows us. And I'll shift that up so it's above the slope. Good, okay. So there we are, that's a 44% side hill. And we just did a 9% grade. Let's go a touch higher, 12%. Now the average side shot there says 15%. There's a length associated with that, by the way. I can't remember exactly where it is. $15, let's go down a little bit. $10, okay. $29, up a little, oops, too far. $21, $8, $15. You get the idea. You can feel your way along the slope. This is going to be full bench cut probably because my side slope is pretty steep. It's not hugely steep, but it's pretty steep. Now, now we're getting into the switchback area. There we go, 10%. Let's do a switchback here. So that distance there is 43. In other words, if I made a switchback that shape, it would be 20 meters radius. Okay, sounds reasonable. Let's do it about like that. Minus 37%, oh sorry, 16%, that's too steep. And now we'll try and rise up to that point there, again, at roughly %. Oh, this is tricky. Keep looking at the wrong number. Whoops, that's close enough. Now I probably should go in and out of this gully, but you know what? I can do that later. Let's just get to the place we're going. Okay, this one probably should be a little higher. 13%. That one's 12%, and we're there. Road pegging. Now I did that on this one terrain. I can do as many as I want. I got this one done. I'm pretty happy with it. And let's take a look at all the points in there. So this is the points window. It's set up in my screen layout, but just to give you an idea how I got it, it was window, new window, text, points. And a points window can show you various features about points on a feature. I'm just going to add the selected feature, which is the one I just pegged. There it is. And I set this up beforehand to do the average slope, so you can see it's going down to the creek there and then back up. And there's no giant grades in there. Oops, there's a big one. But mostly it looks okay. There's the easting and the northing in there. You can also put in, let's add the side slope. Average side slope. This information can actually be exported. So right now, we have enough information here to do a really rough cost estimate. We got length of road, we've got average side slope, and we've got the grade. So that's going to give us some valuable information. And this can be exported. You could do some rough costing on this. Do we want to build this road or not? Is this a reasonable way to get to that point? By the way, this is a road. What if we wanted to do cable analysis? We could just draw in a new feature here. Let's call it D-line. Another draped feature, draw it with the mouse from there down to there. What does that look like in cross-section? My profile right now is still showing the road. Here's a little trick. You can change the feature that a profile is looking at in the options, but there's a speed key for that. So right now the option says I'm looking at spur 1. I could change that. But I just drew a new feature, so it's selected. If I type F5, there's that D-line feature. You can see it's now saying in the title here D-line 0. And again, we are looking at a 10-to-1 distortion. So maybe for D-lines you want to turn that back to not 10-to-1. There it is, undistorted. So there's a lot of planning you can do inside the terrain module. Back to the plan window. There's my little D-line. Here's my road. I do actually want to do another road along here. We'll do that later. Now let's design this road. Save this. Put it on my hard drive. Let's call it demo. Log for original ground. Now this has a surface in it, and it also has this line that I've just drawn that represents my new road center line. That feature is selected. So now I'm going to go into my location module and actually build a road. File new. Find our folder. There's the design, or pardon me, the surface that I just saved. I'll pick that as my current, or my original ground. And I get this option, use the current feature all points. There it is, there's my road. Now it looks pretty crappy right now, and there's a couple of reasons for that. Let's just sort that out. First of all, what template are we using? Now I have my template table set up to have the default template look like a forest road, but one of the interesting things about this is it's using automatic fill slope for cut and fill on the outside. So my fill slope looks like garbage until I give it a sorry, I had a cough. Until I give it a reasonable material type. So let's do that. The default material that's being assigned as fill is existing layer 1. Well, that sounds reasonable. What is existing layer 1? Under assign parameters by range, I can change what material is in the ground. So let's put in something sensible there. How about hardpan? Okay, obviously you can set up your own materials here. I encourage you to do that. And each material comes with its own properties. So hardpan has got a cut slope and a fill slope that are well defined. You can change all that stuff. Right, so I'm applying hardpan, add, edit everywhere, and immediately my cross-section will sort itself out because now I have a reasonable material in the ground. And is everything else okay about that cross-section? It looks okay. It's about 3 meters wide each side, or 6 meters total. Got some crown on it, and seems reasonable for a forest road. Immediately looking at this, I now see an issue here. Looks like that should be full bench cut. This is where we've got our steep side hill. Okay, well, let's start designing the road. Now, the road pegging I did in the terrain module. You can sort of do that in the location as well. There's nothing wrong with me going to the end of the road here and adding more alignment. The problem is that the average grade between the point that I just created and the previous point is not easy to figure out in the location module. We're going to add some more pegging features to allow you to do that. So maybe in the future, that whole process of drawing the alignment and watching the grade, watching the side slopes, maybe you'll do that in the location module. The process will be the same. Okay, so let's look at the, first of all, I think I'm going to put in a couple of horizontal curves. There's really no correct order in this, so that's why I'm hesitating. I think I'll put the horizontal curves in first. You can do it after the fact too, but this is such a sharp corner. I want to make sure that it's a reasonable radius. So I'm going to put in a horizontal curve. I'll just get a different screen layout that's set up for me. Screen layouts are so powerful because you can, at the click of a button, have all the stuff available, like, for example, the horizontal curve panel and the mass hall diagram that you set up once before, but you don't have to remember how you did it. Okay, so I want to put in a curve around this switchback. I can't do it with one curve. I have to have at least 2 IPs, so I'm going to put one IP over there, delete this one, move that one over a little bit. There we go. And let's put some curves on there. So what does my default curve look like? Okay, there's a lot of detail in here. If you were building a, this is the settings in the screen layout. If you were building a rural road, public road, you probably want to see all this stuff, super elevation table, all that kind of stuff. But I'm not. I'm building a forest road. I'm just going to make it more simple. First of all, I'm going to reduce my minimum radius to 25. Can you hear me? Somebody somebody please type in the questions window. Yeah, I'm back. Okay. Sorry about that. Okay, so a few minutes ago, what did we miss? Well, I was busy designing the road. I was putting in a horizontal curve, and I'm just going to set up my curve parameters. This would normally be saved with your default template table. So if I had set this up beforehand, I wouldn't have to go in and change the radius. Gee, we're working in a forest road, so let's take our K factors down to 3 and grades up to 15. Maybe we'll leave the adverse grade at -10 and the favorable at 15. These are just guidelines. You can go over them if you want. And design speed, how about we put that down to 40? Now here's the other important point in the road class specification. I can actually say, you know what, I only want to see the simple stuff. Click on OK, and you'll see that now my curve panel is just a lot simpler. So I'm going to put in a curve, let's say 25 meters. Apply. That looks good. Let's set that as my default curve. Go to the next one. Apply the default. There we go. Now we've got two 25-meter curves, and I can actually play around by moving the IP until you hear that little beep, and they bump into each other. Now I've got a continuous 25-meter switchback. Other places I might want curves, not too sure yet. I might need curves in this area. That's pretty sharp corners, or maybe down here. Really, it's up to you. I'm going to leave it like this for now. And now I'm going to start doing the vertical alignment. So let's look at the vertical panel. So this is just road edge. I mean, you should know a little bit about road edge. This seminar is more about road pegging and the kind of things you can do as a whole rather than the details of road edge. But there's my road, and you can see that by being careful about watching my grades as I was pegging that road, I really did build something that had a pretty steady grade to it. Okay, so let's put in the vertical alignment. That's my finish point. That's my start point. We're going to have the bottom here, so we're probably going to want two IPs, one before and one after. Let's zoom in on that. Something like that, with a flattish bridge, and there I will need curves. We've got big grade breaks. You can see that we're going from -9 to 0 to 13. So let's put some curves in there. Again, first curve, let's try K of 5 and see how that looks. Oh, that's not too bad. Okay, I'm going to set that as my default. Go back to the previous IP. Okay, now we got a bit of a curve in our bridge. To avoid that, I'd have to go like this. Then I got lots of cut over here. Okay, we're going to have some issues, but let's not worry about it too much right now. Somewhere along here is my switchback, and I want the grade to be a little less in the switchback itself. How can I find it? I just jump over to the plan window, move my current point to the switchback. Here's a little trick. If I go to Selection Tool, I can just click anywhere and look at the cross-section, right? But if I'm busy editing and I click somewhere, oops, it's going to cause me to edit the design. If I hold the Control key, the cursor changes to the Selection Tool, and I can click anywhere without modifying my design. So that's a nice little trick. Hold the Control key, click to select, and then you're back to edit mode. Okay, so there's my switchback. I'm right in the middle of my switchback. At least that's what the current point is showing. Now if I flip back to my profile window, there it is. So we want something like this probably, where the grade in the switchback itself is a little bit less. Again, we could put vertical curves there if we wanted to. The grade break is quite large, 7 to 13. Well, that's a curve. 13 to 5 to 15. So there's big grade breaks in there. We probably should put some curves in. So I'll do that. And next curve, get default, apply. Good. Okay. Okay, we're starting to get there, but boy, do we ever have some big cuts and fills. 60,000 cubic meters of fill. This is going to be an expensive road. So let's look at the plan window. Here's where the fill's happening. Dash green line is my toe fill. Let's take a look at a cross section. Hold the control key, click, and oh yeah. So really, if I were to get this into full bench cut mode, these problems would go away. So rather than fiddling around in the profile, go back to the profile, and trying to lower it down so that I don't have so much cut, well, that's going to be a problem, right? We're already at 13% grade here. Yeah, 13%. So I can't just move the grade around. In fact, I'm pretty much at my maximum grade as it's set right there. But I can move in my horizontal alignment, and I can move in and out of the hill to get full bench without changing the grade very much. It does change a tiny bit, because whenever you move the horizontal alignment, you change the length of the road. So the grade between two vertical IPs will change a little bit, but not much. So here we go. Let's take this point here and move it uphill until, okay, we got problems with the curve. Let's just go back to there. Okay, that's pretty steep, but that's okay. We're coming into our switchback. This may be necessary. But just before that, we can go uphill a little bit. There we go. Now that's almost full bench. Notice immediately you see the effect in the plan window. You can see that the slope stakes coming back up close to the road. Here's a little trick. If I want to do this sort of work where I am, well, let's just do another point. First of all, let's take this point here and move it uphill. And, oh, that's not far enough. Let's go uphill a little further. And there we go. That's full bench, but it's too far. I've got a ditch on the downhill side. I don't need that. So I'd like to go back a little bit. Eventually, I'll get it right. Here's a trick. I want to move horizontally in the section window. So I'll go into my section options, turn on horizontal only. You don't want to move both. If you're working in the section window, you want to move either horizontal or vertical. And whichever one you're doing, you want to watch the appropriate window. I'm going to move horizontal. I'm going to watch the plan window while I do it. So I can just go over to this thing and just move over a little bit, move over that way a little bit. Looks like I could use some daylighting here. So let's go back to my template editor, turn on daylighting. How about 3 meters? Okay, what does that do? This is the old forest road template. It has daylighting built in. There are some more sophisticated templates that have daylighting as well. What daylighting does is that. You can see if I move the template over, eventually I get a ditch. But if I move it back towards the hillside, when I get within 3 meters, it just cuts straight out instead of cutting in a ditch. So that's what we call daylighting. Great. Okay. So I've turned daylighting on. Did I actually say OK to that, or did I say cancel? Darn, I said cancel. Let me fix that. OK. So roadway, daylighting of 3, well, let's make it 5 meters, both sides, OK, and OK instead of cancel, recalculate, and the daylight line appears. Great. Now, I'm just going to move ahead, back actually, till I get to another horizontal alignment point, that one right there, to the plan window and move it over. Keep moving it over, not the plan, the section window, until, there you go. Now we've got not full bench, but at least we're not falling off the cliff there. Looks like we're going to need another point in the middle. I could create one in the plan window, or I could just say, let's go back, nope, ahead until we're in roughly the right spot, and let's just move this point over. Click, click again. I created a new horizontal alignment point using the section window. So I'm going to end up basically following the contours to get my full bench cuts where I need them. There we go. And every time I do that, I am reducing the amount of fill. And you can see I'm also changing the ground line to follow the grade. That's what I want. Back to plan. We're almost done here. Let's just get this point over a little bit. Oop, don't have to go that far. This is pretty flat down here. Starting to get steep there. Let's move that point over a little bit. Okay. Well, I basically finished my, at least I've done enough of this alignment to see that it's not going to be stupidly expensive or infeasible. And I can look at things like the mass haul diagram and see that, oh yeah, I'm going to have some extra material, and most of that material is being cut at the end. The beginning here, I'm going to cut at the beginning, and then I'm going to push that across. Looks like I'm going to push it right across the creek, so that might be an issue. Maybe I want to try and do some adjustment of the alignment before the creek, too. So, yeah, let's look at that area. This is lots of cut, but it doesn't look like I have much choice here. I could move those points over a little bit, but not too far, because it's pretty steep. Yeah, I don't know. I'll probably get away with a little fill there. Whenever I move the horizontal alignment, I'm going to have to check vertical. So big monitor, watch them at the same time. Profile and plan can be visible at the same time. I think that's pretty much all I wanted to show you about alignment. Now, the point here is that we started with a Lidar file, which contains very good surface information, pretty good. In the areas with dense trees, there were some gaps of 10 meters between points. Not a big deal when you're doing some preliminary road design. However, the Lidar file doesn't contain any information about the soil, the ground wetness, seeps, stability. It's just not in there. So although I can design a road and get to the point where the location design is creating a pretty reasonable final design here, I mean, I could go out and build this. I still don't know whether it's feasible until I walk the line. So, you know, this is great for doing preliminary planning. You can probably lay out 90% of your roads, and then you go out and walk them and say, yeah, it's going to work. Some cases, you're going to go out and walk them and say, hey, wait a minute, this is a serious wetland here. We got a problem. Let's move the road somewhere else. Or this material that's sitting at 50% side hill is actually unstable, and we can't even do a full bench cut to cross it. It's going to be a problem. That's the kind of information you're going to get on the ground. But the Lidar gives you everything else. Now, I haven't pretty much used up my time. I was going to show you a quick introduction to our optimizer software. But before I do that, any questions about Lidar and Lidar pegging? So once again, if you put your hand up, I will see it, and I can turn on your microphone if you got a mic, or a telephone if you're listening that way. or type something in the questions window, and I'll see that and respond. Good. Well, thanks for that. I must have answered all the questions in advance. Oh, here's a question. Sean says, what is the normal density for collection of LiDAR data? The normal density, I don't know exactly, but I can tell you that most LiDAR providers will tell you 1 point per square meter. Looking at this data, you can see that it's a lot less than 1 point per square meter. Even in the full dense area here, there's gaps of about 10 meters. It's about, and again, it depends how high you're flying and what instruments you're using and so on, but I was told even a few years ago that the vertical elevation accuracy was within 15 centimeters, which is amazing. So yeah, even through trees, you get enough information to do preliminary design. Any other questions? Okay, so we've got a new product out. This is off the topic, but it actually follows nicely from this. Let's say I wanted to build a road from here to there. Let's do it. I'll just create a new road. Let's call it Spur 2. It's going to be a draped feature. I'm going to draw it with the mouse. I'm going to start here. I'm going to finish over there. And I'm going to want to watch both windows here. Let's tile vertically this time. Set up the profile to watch the right window, type F5, there we go. Now we're looking at that, and let's just change that again to a 10:1 distortion. Okay. This is a saddle, you can tell by looking at the contours, so I'm not going to get much of a benefit by moving around here. I'm pretty well stuck with that. But along the way to there, I can certainly reduce the grade here by going like that. That reduces the grade at the end. And this is probably, this valley here is probably wet, probably not a good place to put a road. Besides, where am I going to get material for fill? So I'll go over to the edge of my hill and I'll move along the toe of the hill. I'll try and do that in such a way that I don't have big bumps. So yeah, you know, moving down, that goes down. Yeah, you get the idea. So there's a quick alignment. It is about 800 meters long. And now I'm going to show you our vertical alignment optimizer. This is new technology, and we're hoping to have a beta release out in the next few weeks. So I'm just going to jump over to the location module and do the same thing I did before. I'm going to save this just in case I want to come back to it. So I'll call it Spur 2 demo. And oops, I forgot to save. One thing when you're working with the terrain and the location together, they are separate applications. So you do need to save the terrain before the location can use that terrain. So starting with nothing, I'm going to create a brand new location design, again from that same file that I just saved. The current feature has now been changed, so this is still correct. And there's my alignment. And there's my profile, just like we expected. Now this takes a little while to design. Let's say I wanted to make this a main line, so it's going to have 60-kilometer design speed and vertical curves and so on. It's going to take me a while. I'm going to have to put in some grade breaks, you know, it's coming off an existing road, so I don't think I can go too steep there. Maybe I should set that first grade to, say, 6%. I've done this before, so I'm going pretty quick here. Vertical curves. Okay, so let's bring up the vertical curve panel. I'm just going to use that screen layout I was using before, training normal. And oh, do I need to assign I better assign a fill type too. Same as last time. Put in a curve. How about 20? Let's try 20. Boy, that's a pretty long curve. Let's try 10. You can zoom in a bit so you can see it better. That's a pretty long curve. Okay, let's try k equals 10. Okay, I'm outside sight distance, so if I was serious about this, I'd have to reduce my design speed. Let's say 40. Oh, that looks okay. Okay. Now I can move that up like so. I'm going to need probably a curve on there. So let's go back to that point. Default curve. There we go. Ahead, put the same curve out here. There we go. Look at my mass hall diagram. Let's lower this down a little bit. Oh, I've got lots of cut here, but there's not a whole lot I can do about that. There we go. That's roughly balanced. Now let's see if we can do it with the optimizer. So, again, I've got a screen layout set up for that, but the optimizer is this new button here. It's not available in your software. It looks like that, and here's what it allows you to do. I'm just going to bring in the screen layout that I've been using because it's got a bunch of things set up the way I like it. I'm going to create a optimized alignment that will, oh, here's another point before I get into the optimized alignment. We can set up things like cost for cut, cost for fill, cost for movement. Now I got one already set up, so I'm just going to open it. Okay, oh, and glacial till is the material I need to use here, so let's do that. Change that to GT. No pits defined. Okay. If I'm going to do a realistic calculation, I need to know where the borrow and waste pits are. Why is this? Let's put them at station 0. And I'll answer my rhetorical question. It's a gravel pit. Gravel costs $5. Okay, first of all, I told you we had enough information to cost things when we were designing that road right at the terrain level. You get even more information from location design. You're going to get cross-sectional areas, volumes of materials, and so on. The alignment tool gives you yet another step ahead. By the way, if you're short of time, that's an hour. Thank you for watching. But if you're curious about the optimizer, please feel free to hang around. First thing is, you can't do optimization without costing. So we built a costing tool. Now, it's some of the options that you need to set up a reasonable cost. Okay, it says audio. Let me did we lose audio for a moment there? Anyway, send me a question if you're not hearing. Nope. Okay, good. Things are still clear. So I want to calculate the cost of this road. What do I need to know to calculate cost? Excavation cost. How much does it cost to cut glacial till, how much does it cost to place it to build the road? Movement cost, how much does it cost to move my material various distances? You've got free haul, haul, and overhaul. These are just different distances. Those are set up in your mass haul diagram. Qualities are important. I don't want to go into too many details here, but if you think about it, the only way we're going to figure out the earthwork costs is to assign values to these things. Cost per cubic meter cut, cost per cubic meter fill, so on. Cost per cubic meter movement. Now, even if you don't get these numbers exactly right, it's quite true that when you take a look at a cost, there it is, 63,000, and then you make a change to your alignment and recalculate the cost, you can even do it automatically. Let me just turn the sound down. Now it's 38,000. That's definitely going to be a better road. I mean, unless you've put in some really stupid cost values, it's calculating the the total movement of material and so on. So there's a better road. I've got now a tool to allow me to do my own manual optimization. If I move this over here and recalculate the cost, now it's 23,000. So I'm getting better, getting a cheaper road. And now this is particularly important. I'm doing a lot of fill there. I wonder if I can move up the hill, because I remember where that is. That is, let's go back here for a minute. I probably need to put in some curves, but I'm not going to bother for this example. Right in this area, no, this area, sorry. I got lots of lots of fill. My cross section looks like that. Surely I could move to the right. I can't move down. I'm constrained by my curve here, but I could move to the right or left. Let's move to the left and therefore reduce the amount of fill. And that is, why don't I see the current point on here? Unlock scale. There it is. Okay, it's right there. So I could create a point there and move it up the hill and reduce the amount of cost. And look, now we're down to 20,000. So I've got the tools now to actually do manual optimization. The screen is kind of tiny, but I think we're getting somewhere here. There we go. Okay, so you can see that if I go back a little bit, put in another point, go over there, that's lifting the ground up, which is reducing my cuts and fills, which is, again, reducing my cost. Very powerful tool, instant cost. Now let's look at the alignment calculation, and then I'll let you go. So I want to create an optimized alignment here. Let's see if we got everything set up. Constraints. I need to define the minimum K value. That's essentially my design speed. There we go. Need to design my maximum minimum grades. I need to define any control points. For example, at the start of the road, I need to match the existing alignment, and I probably want to keep the grade under 5%. Let's say plus or minus 2. So that's a control point. You can put in as many control points as you want. I've already set up the pits. You need borrow and waste pits because sometimes the optimizer can't balance. Usually it does. Location of pits, cost of pits can change the optimal solution. If you've got lots of material, your optimal solution near that pit will be different. And we've already looked at the ground types. Okay, so now I'm going to calculate this. Now this is beta software. There's always a chance this is going to crash. So let's do a save here, and I'll call it Spur 2. Oh, last one I called Spur 2. I should have called it Spur 1. Oh well, let's call it Spur 3. Press the process button. Now, something that's important to say here about the optimizer, not only are we, and there it is, the green line is the optimal solution. We're using a real cross-section template here to calculate costs. And therefore, when it minimizes costs and figures out the actual shape of the best alignment, it's using real cross-section template areas, cut areas, fill areas, etc. First of all, a comparison. My design, I got it down to $19,000. Dollars should probably be in quotes. 19,000 cost units. Maybe I didn't get the right cost per cubic meter. Doesn't matter. I got it down to 19 of those things. And the total cost now for optimizing is 12. So I've saved myself almost 40% by using the optimizer to find that alignment. Now, I may have got closer to that after playing around, and I may get even better cost values by changing the horizontal alignment, because this is currently only a costing tool and a vertical alignment optimizer. So I'm going to get a completely different result if I move the horizontal alignment around. There you go. That's it. Powerful tool. Will be available in a few months. It's going to be an optimizer. It's going to be an add-on. We call it Software Optimal. It's going to be an add-on for RoadEng, and it will give you two very powerful things: the cost of any road anywhere, and an optimal vertical alignment, given that you put in reasonable constraints and options. Any questions about the optimizer? Okay, well, let's call it quits for today. Oh, one more thing I just want to show you before we're finished here. The optimal alignment is shown in green on the design here on the profile. Let's just maximize that. So you can see where it should be, but it would be nice to actually have the road there, and I can do that. I can just say set current, and it will put the alignment on top of the optimal. There it is. And you'll notice that it's pretty much designed the same way I did. There's a straight line 10% segment there. There's the K equals 10 curve at the bottom. But you will find these curves in between that join up various pieces of the alignment. Same over here. We are working on a way to prevent there from being so many curves. The optimal alignment naturally is going to kind of be wavy and following the ground as best it can, given the curve constraint. But that doesn't make it easy for me to tweak. I can't just pick up this curve and move it because it's constrained. It's stuck between two other curves. So in the near future, we're going to change the way that it builds curves so that there will be straight line tangents between them instead of all these little wavy curves. Okay, that's all I want to say. Thank you very much for watching. We'll be back next Friday. And that's the end of the webinar for today.